Bismillahirrahmanirrahim. Assalamu alaikum, students.
Walaikum salam.
Walaikum salam rahmatullah.
So today we will solve some problems of chapter number 8. So last time we have solved some problems about chapter number 8. You remember this one? So these are the problems about chapter number 8. So in this problem, a 1.6 kg block slides down a plane inclined at 25 degrees with a horizontal. So it means this is an inclined plane. You can understand like this one. And its angle is 25 degrees. And here is a block. Its mass is 1.6 kg. At a constant speed of 2 meters per second. So the speed is 2 meters per second. It's moving. At what rate is the frictional force changing the mechanical energy of the block? So we have to find the change in mechanical energy divided by the time. So rate mean here time. So it means this is actually, you know that power is equal to energy over time. Energy over time. Or you know that power is equal to force multiplied by the speed. How this formula come? You know that power is equal to energy over time or work done over time, the same thing. Work is what? Force into distance over time, and force into distance over t, and distance over t is v. So if we know the v value, we can find the other these parameters. Okay, actually we have to find the watt. Watt is the unit of power. So what we will do? So first you can make the components of this one. This is the normal reaction, and this is this component, and this component is, this is 25 degree, and this will be mg, and this is mg sine of 25. So the block is moving down. We need the frictional force. So surely if the block is moving down, with which component it is moving down? It is moving with this component. Where will be the frictional force? The frictional force will be in the opposite direction. Okay. So here we will write that mg sine of 25 minus f of k is equal to ma. This is the net force. So here the speed is constant. So that's why the net force is 0. So we will write f of k is equal to mg sine of 25. And f of k is equal to, m value is given, 1.6 into 9.8 into sine of 25. So if we solve this, after this calculation, we can get the answer 6.62 Newton. So this is our frictional force. We don't need to find here frictional force like F is equal to mu into N or mu into mg. We can find like this one. No, we want to find the power by this frictional force. So power by this frictional force is equal to F of k into V. V is given. So 6.62 into V is 2. It is given, the constant speed. So answer is 13.26 watt. Now we want to write and check the answer. You can see here answer is plus and here answer is minus. But you know that frictional force work done is always be negative. So that's why we put here negative. So this is the answer. Okay. After this, see this problem. A 3 kg block is on a horizontal surface. No, the surface is horizontal. It is not inclined. So the block is here. The block is at rest at T is equal to 0. A force of magnitude P is equal to 12 Newton acting parallel to the surface. This is parallel to the surface, to the block, causing it to accelerate. So this force is causing it to accelerate. The coefficient of kinetic friction between the block and the surface is 0.2. Here is the frictional force. So mu k is equal to 0.2. So this problem is related with the previous chapter, but anyhow, we will do this one. At what rate is the force P doing work on the block at T is equal to 2 seconds? So you can also apply here the formula maybe mgh over T, but mgh we cannot apply here because it is not moving up and down. So what we will do, the frictional force is in this way. First find this is mg and this is the normal reaction. So first find in the horizontal direction the net force. Write the net force equation. F of k is equal to m into a. Find the acceleration, because if we find the acceleration, we can find the velocity and then we can find the power. We want to use the formula power is equal to force multiplied by v. To find v, first we have to find a. So a is equal to p over m minus f of k over m. So p is 12 over 3 minus f of k. So f of k is what? F of k is mu k into mg. You know that this is f of k is equal to mu into n and mu into mg. So this is divided by m. This m will cancel and this is 4 minus mu k value is 0.2 multiplied by 9.8. So when you multiply this one, its answer will be 1.96. And this is equal to 2.04 meter per second square. So this is the acceleration. After this, now we want to find the final speed. So final speed is Vf is equal to Vi plus At. So here Vi is 0 and A is Vi is 0 because it is starting from the at T is equal to 0. So this is 2.04 and this T is given in 2 seconds. You can see here, this is the 2 seconds at the end. So when you multiply this one, the answer of Vf will be 4.08 meter per second. Now, we want to find the power. Power is force multiplied by V. So force is already given 12 into 4.08. So when you solve this one, answer will be 49 watt. So this is the answer. So in this way, you can solve this problem. Okay. After this, already we have solved this problem in the last lecture. You remember this one. Okay, now I want to solve this problem. So in this problem, you can see the stone rests on spring. So this is the stone. It is rest on the spring. The question is what? Figure this one shows an 8 kg stone. Mass is 8 kg. Stone at rest on a spring. The spring is compressed 10 centimeter by the stone. Surely when the stone will be here, the spring will be compressed. So the spring will be like this one. Here there is the stone. How much it is compressed? It is compressed by 10 centimeter. So x is equal to 10 centimeter. So this is equal to 10 over 100 and this is 0.1 meter. X value is this one. The first question is, what is the spring constant? Spring constant mean K value. So K is equal to F over X. Here F is what? Mg. over x, and k is m is what? M is given 8 into 9.8 divided by x 0.1. So if we solve this one, then k value will be 784 Newton per meter. This is the first question, this one. After this, the stone is pushed down an additional 30 centimeter. Additional 30 centimeter mean 10 centimeter already and more 30 centimeter. So the total x dash will be 40 centimeter. So 40 centimeter mean 30 plus 10. So this is x dash is equal to 0.4 meter. The question is, what is the 30 centimeter? What is the elastic potential energy? What is the elastic potential energy of the compressed spring? So the elastic potential energy of the compressed spring is 1 over 2 kx dash square. So 1 over 2 into k value is this one, 784 into x dash is 0.4 square. So when you solve this one, you will get the answer 62.72 joule. What is the change in the gravitational potential energy of the stone earth system when the stone moves from the release point to its maximum height? So change in potential energy will be the same like this elastic potential energy. So we should write here 62.72. This is the same one. The next part is, what is the maximum height measured from this release point? So it means when the spring is compressed, it is potential energy of spring, and this is equal to what? It is releasing. When it is releasing, the stone will go up. This is the spring, suppose, and the block is here. When you compress this one, then it will be here. Okay. When you release this one, it will go up. So here is the potential energy of the spring, and here is the potential energy of the stone. So 1 over 2 kx square x dash square is equal to mgh. So we want to find h value. To find h value, what you will do? 1 over 2 kx dash square divided by mg. So 1 over 2 kx dash already we have found. This is 62.72 divided by m, and m value is 8, and this is 9.8. So the answer will be 0.8 meter. How much high it will go? 0.8 meter. So in this way you can solve this problem. Okay. After this, this is also same type of problem, but I will solve the next problem. Next problem is more complicated than the previous this one. That is a little bit easy, but this is difficult. So block on an incline collides with a spring. What is here? The block is coming and collide. This is the situation. Now you can see in the problem in figure this one, a 12 kg block, mass is 12 kg, is released from rest. It means its initial velocity is 0. On a 30-degree frictionless incline, there is no friction. So the angle is theta is equal to 30 degrees. Below the block is a spring that can be compressed 2 centimeter by a force of 270 Newton. So if we compress this spring 2 centimeter by applying this force, the block momentarily stops when it compresses the spring by. So this information is actually to find the value of the K. So K is equal to what? F over X. So F is 270 divided by 2 centimeter. 2 centimeter means 0.02 meter. So when you solve this one, you will get the answer 13500 Newton per meter. This is our K value. Now the question is starting the block momentarily stops when it compresses the spring by this one. This X is different and this X is different. Now the question is starting here. When X dash is 5.5 centimeter, the block is momentarily at rest. Okay. The question is, how far does the block move down the incline from its position, rest position, to the stopping point? So we have to find this X value. This X dash value, this X value we have to find. Now you can see here, first what we will do, we will take 3 points on this block. One is this A point, one is this B point, and one is this C point. First, I am taking the 2 points, one this highest point and one is this point. Okay. So I want to write the equation, law of conservation of energy at point A and at point C. So at point A, So if I write the equation, it will be kinetic energy at point A plus the potential energy at point A. Okay. At point C, the kinetic energy at point C plus the potential energy at point C, because this is law of conservation of energy. So if they are equal, then I will write Ka plus Ua is equal to Kc plus Uc. What is Ka? Kinetic energy at point A. It will be 0 because the block is at rest. So this is 0 plus potential energy at point A. So surely it has potential energy, and this is mgh. I'm writing here mgh. Kc, potential energy at kinetic energy at point C. So you can see here the block momentarily stops when it compresses by the spring 5.5. Momentarily stops. Stops mean rest. So this is 0. Okay. Plus potential energy at point C. So this potential energy will be the spring potential energy, not the gravitational. And it is 1 over 2 k x square. I'm writing like this one. Okay. So this is X is actually X dash. Now I want to find this H value. From here, what I will do? I will find the H value. So H value is equal to 1 over 2 kx dash square divided by mg. So when I solve this one, I will get the value 0.174 meter. It means my height, this is 0.174 meter. Okay. Now, in the other questions, what he is asking, how far does the block move down the incline from its rest position to the stopping point? So we have to find the distance from this point to this point. So the total distance is, if I'm saying that this distance is d, then this distance is x dash. So the total distance will be what? The total distance will be x dash plus d. This is our total distance. So to find this total distance, what we have to do? I make this triangle. This is h, I know, and this total distance is x dash plus d, and this is angle theta. So from this triangle, what I will do? I will find h over x dash plus d is equal to sine of theta. So I need actually x dash plus d. So x dash plus d is equal to what? It will go here and it will go here. So h over sine of theta. I'm writing theta. So you can see that this h value is what? So can we find that this h value is 0.174 and sine of 30. So sine 30 is 0.5. You can solve this one and get the answer of 0.35. So this is the ax dash plus d. Okay. So D value will be what? So D value will be, I'm writing the D value because I need D value 0.35 minus X dash. So 0.35 minus X dash mean 0.055 because this value is 0.55. We know this one. So when we solve this one, we will get the answer 0.292 meter. So this is the D value. Okay, after this, now to find this D value, what we will do? We want to apply, see this one, this is a block and this is the spring and this is D and this is X dash. This is A point, this is B point, and this is C point. We know this is H. Now we are here. We want to find the speed at point B. So we apply the law of conservation of energy at point A and at point B. Now we are considering these 2 points. So to consider these 2 points, I will write the equation Ka, kinetic energy at point A, plus potential energy at point A is equal to kinetic energy at point B plus potential energy at point B. So kinetic energy at point A is 0 because the body is at rest here. Potential energy at point A is mgh is equal to kinetic energy at point B. It is not 0, but it is 0 here, not here. So we write mvb square. We need VB plus UB. UB mean we need this height. To find this height, again, we are in trouble. So if I'm saying that this height is, if I draw the line here, I know that this height is H. If I'm saying that this height is Y and this line is D and this is 30. So can we find the value of Y? Yes, we can find the value of Y from this triangle. Y over D is equal to sine of 30. So Y is equal to D sine of 30. So Y is equal to, so already we have found the D value. D value is 0.29 in the previous slide, and this is 0.5. So when you multiply this one, we will get the answer 0.29. Not a 0.29, 0.146 meter. This is our Y value. Okay, so if we have Y value, then we can write here mg. This is, I can write this h minus y. So we can solve this one. H minus y. We have now y value, we have h value, every value we have. So this is mgh. mgh. Okay. And this is 1 over 2 mvb square plus m into g into h. So H value was what? H value was 0.174 minus Y value 0.146. So you can solve it. Here M is cancelled throughout. So we can solve this one. This is G. G is 9.8 and 9.8 into H. H value is 0.174. 1 over 2 VB square plus G is 9.8. Now you can solve this one yourself with the help of the calculator. Okay, if you need to solve, I try to solve this one. This is 0.174 minus 0.146. So the answer is 0.028. This is 0.028. So when you multiply this one and multiply this one, and this answer is 9.8 multiplied by 0.174. So this is 1.705. 1 over 2 VB square plus 9.8 multiplied by 0.028. So when you multiply this one, the answer is 0.274. So what we will do? 1 over 2 VB square is equal to 1.705 minus 0.274, and VB square is equal to 2 into 1.705 minus 0.74 and under root. Here this is cancelled. Now you can solve it and get the answer. So in this way, you can solve this problem, and we need this VB value. We want to find this VB value. So to solve this problem, what is our aim? The aim is this one, that if you want to find the height of this inclined plane at any point, what you will do? You will draw a line like this one. If you need this height, you will draw this line. First find this like this one, and then subtract this height from the total height, and then you can find this height, because we need this height for potential energy. So to find the potential energy at this point, we need this height. So to find this height, we will take this triangle. Otherwise, we cannot find this one. And same way, you can solve this problem. This is a little easy problem. This is not a difficult problem, but this is difficult. Okay. After this, now see this problem. The block shown is released from rest when the spring is stretched a distance t. So it means the spring is stretched. So stretched means this one. This is a spring mass system. So it is here, and the d value is this one. So K value is given 50 Newton per meter, and M value is given 0.50 kg, and D distance is given 10 centimeter. You will convert it into meter. So this will be 0.1 meter. And the coefficient of kinetic friction between the block and horizontal surface is equal to 0.2. So it means the coefficient of friction is 0.25. This is given. Determine the speed of the block when it first passes through the position for which the spring is unstretched. So mean what? When you release this one, surely it will pass from this position and go ahead. So he is asking, find the speed at this position. So to find the position, to find the speed at this position, what we will do? We will apply the same work done by the frictional force plus work done by the spring, and this is equal to delta K. So work done by the frictional minus F of K into D plus spring 1 over 2 Kx square, but here it is D square. Change in kinetic energy 1 over 2 mv F square minus 1 over 2 mv I square. Now here Vi is 0, and the final here Vf, here Vi is 0, and here I am writing Vi is 0, and here we want to find this Vf. Vf mean we want to find V. So 1 over 2 mv square, this is 0. So minus F of K minus mu K into mg. You know that this kinetic friction is mu K into N, and N is mg into D plus 1 over 2 kd square. So we need this V value. So here everything is given, D is given, mu K is given, M is given, G, you know, K is given, and D is given. Putting the value and solve for V and solve it. And the answer will be, here answer will be 0.70, maybe 7 meter per second. But you will write the answer in 70.7 centimeter per second, because the answer is in centimeter, or you can write it 71 centimeter per second. So this is the answer. Okay, here in this problem, this is the problem like which we have solved in the chapter number maybe 2, 3. So here we will apply the law of conservation of energy. The two masses in the figure are released from rest. After 3 kg, mass has fallen 1.5 meters. So it is fallen by 1.5 meter. Is moving with a speed v is equal to 3.8 meter per second. What is the change in mechanical energy on the system during this time by the frictional force on the 2 kg mass? So the change in mechanical energy is equal to kinetic energy plus potential energy. This is the formula. So here just putting the values, delta U is what? Minus mgh. It is going down, okay? And plus delta k. So delta k will be half mv square. But which m we will take? We will take both m here because both masses are moving. So here delta E is equal to minus mg. So minus mgh mean minus 3. This is moving down. Okay, minus m 3 9.8. How much distance it is moving? 1.5 plus 1 over 2. Total mass is what? Total mass is 5. So into v square. So v is given 3.8 meter per second into 3.8 meter per second square. So you can calculate this one by calculation method and your answer will be around minus 8 joule. So this is the problem. So in this problem, the same situation exists, applying the law of conservation of energy. Okay, let's see this problem. So here I'm writing the equation that kinetic energy final plus potential energy final mean kf plus uf plus u of spring, because here is spring, okay, is equal to, I'm writing here potential energy by the spring final, this is by the spring final, and this is equal to kinetic energy initial plus potential energy initial plus spring potential energy initial. Okay, this is for spring. So in this problem, kinetic energy final, surely the body is moving down, so it will be mv square. Potential energy final, because it is going down, so potential energy will be 0. What will be the kinetic potential energy by the spring? It is not 0, it is kx square is equal to kinetic energy initially it is not moving, 0, plus mgh, because initially it is how much distance? It is some distance it has given, plus in this side no spring, 0. Now you apply this equation and solve it. So this is equal to 1 over 2 mv square is plus 1 over 2 kx square is equal to mgh. So here we need the v value. So just rearrange this equation. 1 over 2 mv square is equal to mgh minus 1 over 2 kx square. Kx square. Now you can solve it for v. So how you will solve? V square is equal to 2 into mgh minus 1 over 2 kx square divided by m. So under root and under root, this will cancel. So V is equal to 2 into mgh divided by m. Okay. And minus 1 over 2 kx square divided by m. So you can write like this one. So solve it for V2, this is under root, and 2 into g of h minus 1 over 2 kx square over m and under root. So here you can solve and put all values are giving, putting the values and solve it. This is easy for you. Okay. After this, we have this problem. In this problem, this is nothing, but here the height is given. This height is h. So surely it has here, if I apply at this is point B, this is point A. The problem is this one, the ball is rolling and moving in this way. So we want to find the position of this is here from this ground. If this is R, this is R, so the total will be 2R. So here the height is 2R. So at point B, the kinetic energy at point B plus kinetic energy at potential energy at point B is equal to kinetic energy at point A plus potential energy at point B. We apply this equation. Other is nothing. So at point A, you know that at point B, kinetic energy, it is starting from here. This is 0. What is potential energy at point B? mgh. What is kinetic energy at point A? Surely it has kinetic energy and 1 over 2 mva square. What is potential energy at point B? mgh. This h is here, but here h is 2r. Now, this is your equation. Now, from this equation, you can solve any problem, either this one or any other. One thing. The second thing, in this problem, he is asking how large is the normal force on it if its mass is 5 grams. So the normal force he is asking about point A. So you know that at point A, the normal force and the weight are downward. So we can write the equation N plus mg is equal to, it's moving in a circular path, mv square over r. So N will be what? mv square over r minus mg. So from this equation, you can find the normal force. But if the body is here, then the normal force is upward, the weight is downward, and then you will write the equation N minus mg is equal to mv square over r. Then you will write this equation. So in this way, you can solve this problem. So this is all about chapter number 8. And next time, in the next lecture, I will start chapter number 9. So before this next week vacations, I try to finish chapter number 9. And then we have left only one chapter, that is chapter number 10. Okay, see you in the next lecture. Assalamu alaikum.
Thank you, Doctor.